happy people of the statistics world. This is Mr. Wilcox coming to you again from my kitchen table. I hope you're all doing well. Yesterday we talked about how to find a z-score given a value, its mean, and its standard deviation. Today we're going to talk about how to use a z-table, and then tomorrow you should be putting that all together. So today we're going to talk about using a z-table. So if you have a paper copy of the packet, your very last page, you can rip it off, is a z-table. It looks like this. And then it has two sides. It has a positive side and a negative side. If you don't have a paper copy, there should be one on Brightspace for you. If you cannot find it on Brightspace, all you have to do is Google standard normal probability chart or a z-chart or a z-score chart. All those things will get you the same thing. There are a ton of them online for you to print off and use or have in a different tab and use. So first we have to talk about what a z-table is. I'm going to pause for a second so you can pause the video and write these things down in your notebook. All right, so I'm going to hold up the positive side of the z-table here. You can see on your y-axis, your vertical axis, you have all one decimal point. So we're going to have z-scores to 2 decimal points. So your first decimal is on the y-axis. And if you look at your x-axis, you have your second decimal point. So I'm going to go through an example on the next slide of exactly how to read this, but that is what we're going to do today. We're going to have a z-score that's 2 decimal points, and your first one's going to be on the y, second one is going to be on the x, and that number you find in your table is the probability that a value is less than or equal to that, or that the area under the graph to the left of that is that proportion. So remember, there are two ways to think about a normal probability curve, and that's either the area or the probability. Today we're going to be focusing on area a little bit because it's just easier to start a z-table thinking about area, but there are two ways to think about it means the same thing. So again, it's going to mean either that proportion of the area is to the left of that, or that the probability of a value being less than or equal to that value is that probability. So you do not need to write down the table here, but you might want to write down the answer. So this is just a small clippet of a standard normal distribution table or a z-table. So again, on our y-axis is our first decimal point. On the x-axis is our second decimal point. So if we wanted to find our probability of being to the left of 1.33 or a value being less than 1.33 on a standard normal distribution curve, we're going to go to 1.3 because that's our first decimal. And then we're going to go over to 0.03 because that's my second decimal, making it 1.33. And so our probability there is 0.9082. So the area under the curve, the proportion of that is 0.9082 or 90.82%. And the probability that a value is less than or equal to 1.33 on a standard normal distribution curve is 0.9082. So you're going to find the first decimal point on the y-axis, second decimal point on the x-axis. Where they come together is going to get you your amount of area or your probability. So we are going to go through a few examples. Unfortunately, I can't really hold the z chart up for you to see what I'm doing, but I am going to talk through it. So I'm going to pause for a second to give you time to write down these two examples, and then we're going to do 2 more examples on the next slide. All right, so hopefully you have these 2 examples written down. So we want to find the area under the standard normal distribution curve. Remember, that just means we changed it so that our mean is 0 and our standard deviation is 1, and we're looking at probabilities that way. So the number on the actual Z chart gives you the proportion of the area that is to the left of a number. So for these two questions, we just have to find the proportion of the area under that by just looking up the number for the Z-scores. So if you flip to the negative side of your Z chart, you're going to find negative 2.4 on your y-axis. And then you're going to go over until you have 0.05. So if you do that, the number you should get is 0.0071. So that is the proportion of the area to the left. You could also write it as 0.71%. Those would be a both correct way to look at that today. So for the second one, if you want to find the area to the left of 2.90, again, the number on our chart actually gives you the proportion of the area that is to the left of that. So we just have to find the number that corresponds with the z-score of 0.290. So flip it back over to the positive side. If you go back down to 2.9 and over 1 so that it's 2.90, the number that you should find there is 0.9981. There's a point there. All right, so hopefully you found those numbers. If not, make sure you are getting a hold of me in one of the many ways you can get a hold of me, or watch the video how to find a z-score that I found from YouTube. It does a great job showing you how to use a z-chart. All right, so I have two more examples for you. One is going to find the area to the right of something, and the other is going to find between. So if we want to find the area to the right of 2.23 standard deviations above the mean, so if we're looking at our normal curve, remember on a standard one, this is 0. And what the table will give us this area. But what we want, if we're looking to the right of it, is the area over here. So if we want the area over here, we're going to take 1 minus whatever our value is on the z-score, because that's going to be what's to the right. If the chart gives us what's to the left, 1 minus that should give us what is to the right. So we have to find our value on our z-table that for 2.23. So go to your positive side of your z-chart and then go to 2.2 and then over to 0.03. And the number you should get there is 0.9871. So if we take 1 minus our 0.9871, we get 0.1290. Oops, that's not right. Oops. 0.0129 or 1.29%. Sorry about that. Forgot a 0 in the decimal point. So that means 1.29% of our area is covered by to the right of 2.23 standard deviations above the mean, or the probability of being bigger than 2.23 standard deviation above the mean is 0.129. Now, if we wanted to find something that's between, I'm again going to draw a table so you can see what we're doing. If we have a z-score and it gives us this area, and then we have a z-score and it gives us this area, the area in between is going to be our the area of the bigger one minus the area of the smaller one. So what we're going to do is we are going to find the z-scores for both of these. We're going to find the z-score for the bigger one first and subtract away the z-score for not the z-score, we're going to find the probability for the bigger one using our z-table, and then we're going to find the probability of the smaller one using our z-table, and we're going to subtract it. So our bigger z-score is 2.55. So if we find our value on the positive side, go down to 2.5 and over to 0.05, where those meet, your value is 0.9946. And we're going to subtract away our value for our smaller z-score. So our smaller z-score is negative 2.55. So if you flip your sheet over and go to negative 2.5, and again over to 0.5, we get 0.0054. So if we subtract those two probabilities, we're going to get the probability in between. And so our probability, or the proportion of the area in between here, is 0.9892. So that means 98.92% of our data is in between those two values, which does make sense because remember, between 3 standard deviations is 99.7. So this should be pretty close. So hopefully this helps you use a z-table. If you have any questions, please make sure you get a hold of me. I hope you are doing well. I hope you're healthy, and I hope you all have a great day.